Hello, Math 243 students. Today we're going to be talking about histograms, section 2.2. A histogram is just a special type of bar graph. It consists of contiguous or adjoining boxes, so there's no gaps between the boxes. The horizontal axis is special. It is divided into bins or classes. Both of those words are used. Some people call them bins. That's generally what I call them. Some people refer to them as classes. On the vertical axis, it is either the frequency of each bin or it is the relative frequency. And we're going to jump in and make sure we understand the difference between those two things. And a good rule of thumb is that you would use a histogram when your data set is 100 values or more. It's not as useful for smaller data sets. Let's look at an example. The Wind Mountain excavation site in New Mexico is an important archaeological location of the ancient Native American Anasazi culture. The following data represent depths in centimeters below the surface grade at which significant artifacts were discovered at this site. And you can see along the horizontal axis is our bins or our classes. And so this first class is from depth of 10 centimeters to a depth of 48 centimeters, including 48 centimeters. That's what the square bracket means, remember. So anywhere between 10 and 48. The next bin goes from 48 to 86, but doesn't include 48. So 48 would go in this bin, but 86 would be included here. 86 to 124, 124 to 162, and 162 to 200. So looking at this, what is the bin size? The size of these bins is going to be equal to the difference between these two numbers. So 48 minus 10 is 38. Likewise, 86 minus 84, I hope that is also 38. Let's grab our calculator really quick and check. So I'm grabbing my calculator and I take 86 and I subtract from that 48 and I get 38 again. So each one of these is equal to size 38. Oops, I used the wrong pen. Sorry about that. So my bin size is equal to 38. And I just did each of those high numbers minus the low numbers. All right, so let's answer some questions about this histogram. First question is, how many artifacts were found at a depth of 86 centimeters or less? So 86 centimeters or less are going to be anybody in this category. That's between 10 and 48, and anybody in this category. So we simply add up the two numbers. There were 40 found in 48 to 86 and 14 found in 10 to 48. 40 plus 14 is 54 artifacts. All right, why don't you guys try the second one? Just pause the video and see if you can answer the second question of how many artifacts were between 86 and 162 centimeters. All right, did you come up with 13 plus 5? So 86 to 162 would be in these two. 13 plus 5 is 18. Last question. What is the sample size for this data? Remember, sample size is one of our vocab words. Sample size is the total number of data points. Well, we're going to add these all up. We're going to take 14 plus 40 is 54. 54 plus 13. Let's actually just add them up for 40, 14, 40, 13, 5, and 1. Add those guys all up. We get 7, 12, 13. Carry the 1. 1, 2, 6, 7, 73 artifacts. So this is a little bit of a small data set for a histogram, but you get the basic idea. All right, let's keep going. Let's say we want to learn how to construct our own histograms. In fact, we do want to. First thing we need to do to construct our histogram is we need to decide on the number of bins we want to use. There is a good rule of thumb that if you look at the sample size, if there are n values of data in your sample size, you're going to take the square root of n and then round up to the next integer. So let's say we had a data set of 200 values. The square root of 200 is 14.14 approximately. So we would round up to the next highest integer, the next highest whole number, and we would get the total of 15 bins as our choice. All right, so we're going to practice and we're going to make our own histogram using Desmos. The following data is the height in inches to the nearest half inch of 100 male semi-professional soccer players. All right, let's begin and create a histogram with this data. The first step to creating a histogram is typing the data into Desmos. You can either type it in, literally type in every single data value, or we can follow a link where I've already shared the data with you. Let me show you how to follow that link so you don't have to type in 100 different data values. If you go to our MyOpenMath page, under the 2.2 video section, you'll see here is the link to the Desmos used in the video. Go ahead and click that link, and it will open a Desmos page. Here is all the data typed in this X1 column in the very first thing. So that's what you should see when you follow this link. The next thing we need to look at is we need to figure out the bin width. Now, remember we did a rule of thumb for the number of bins, and the number of bins is equal to approximately, remember, the square root of the data size. In this one, the data is 100 values, so the square root of 100 is equal to 10. So we're going to pick 10 bins. So to calculate the bin width, you take the max value of the data minus the min value of the data and divide by the number of the bins. Let's scroll back and look at the data to pick out the max and min values. Conveniently, this data is sorted from smallest to largest. So the smallest value is 60 inches and the largest value is 74 inches. So we compute 74 minus 60 and divide it by 10. That gives us 1.4. I'm going to go ahead and round that up to 1.5 because it's a little bit easier to read histograms if they are on a nice half, or the data is in half-inch units. So it makes more sense to me to go up to 1.5 for each bin size. So let's go ahead and go back to Desmos, knowing our bin size now of 1.5 inches. All right. Again, here we're back in that same Desmos that you followed the link for, and we're going to go here to the second command window, and we're going to go ahead and draw a histogram using this data in the column labeled X1. I'm going to move this off to the side here because I need this little keyboard thing. So click on the keyboard, show keypad, and go over to where it says functions. All right. You can scroll down until you get to visualizations, and we're going to choose histogram. You could just type histogram if you wanted to, too. The first, it asks for two things in creating a histogram. The first thing it wants to know is the data set. Well, remember, our data is listed under column labeled X1. That's the name of this column, X1. So we're going to come in and just type in X1. X. And sure enough, it makes a nice histogram. The next thing we want to put in is the bin width. It picked a default bin width of 1. If you saw before that, it says bin width equals 1. That was its default. We really want a bin width of 1.5, so we're going to type in 1.5 and then right parenthesis to finish it. We have a couple of more options that we need to look at. The first one is bar heights. Do we want count, relative, or density? Well, right now we want count. We're not doing relative frequency, which is like percent in each category. So we're going to leave that as count. And then bin alignment, it says either center or left. I like to use left. I think it's easier to read what my categories are. So looking at my histogram, you can always click this nice little button that I just clicked right there. Of course, I messed off it now. Do you see this little magnifying glass with a plus sign? That's zoom fit, and it will always get you a nice window for your histogram. The reason I chose left bin alignment is because now as I look along my horizontal axis, this category starts at 60, 60.5, 61, 61.5 is where the next bin starts. So it's telling me I have, I'm looking at my categories on my y-axis. It looks if I'm going by, if there's 10 here, that means each of these are 2, 4, 6, 8, 10. So that tells me I have 4 data values between 60 and 61.5, which if I look at my data, I can see that that is true. I have 60, 60.5, 61, and 61. So I have 4 data values from 60 to 61.5, and then 1 only from 61.5 to 62.5. And if we want more numbers on our x-axis, we can certainly put those in. So let's go to graph setting, and let's go with a step of 0.5, and then that should be a little bit better. You can see our data values. Well, maybe not. I thought that would make it do it. I don't know why it's not adding my step values in. Maybe I just need to zoom. I'll have to go back and figure that out. I thought that would make it go every single one, but it doesn't really. That's okay. We'll just make it work for now. So you'll just have to count for now. So this is 62.5, so I'm going by 0.5s here. All right, I actually just had an idea. Let's go ahead and adjust that one more time. Instead of doing steps by 0.5, let's do steps by 1.5, and then I think that will actually label it the way we want it to be labeled. Yeah, there we go. So now this bin goes from 60 to 61.5, but the actual value 61.5 is in this bin. This bin is 63 to 64.5, et cetera, on up. So we made a nice histogram there. You can play around with this a little bit if you want to change the color, add a title, all that. But for now, this is enough for our histogram building. Let's go back and talk a little bit more about histograms. All right, what we're going to do now is we're going to do one more histogram, and we're going to do this one completely from scratch, which means putting in all the data sets. This is a smaller data set, so we don't have to type in quite so much. So we're going to do the following data is weights of 30 pumpkins from a pumpkin farm. Let's go ahead and type this data into Desmos. So going back to Desmos, we're going to get a whole new graph. We're not going to mess with this one. We're going to get a whole new graph by going up to the 3 bars and opening a new graph and then just clicking blank new graph. All right. So now what we're going to do is we're going to put in our data set. You go to the plus button for add item, and we're going to put in a table of values, right? Just like we did before. We're going to put all our data in the X1 column. We don't even really need the Y1 column. We're just going to ignore it for now. Our data set says there are 9 pumpkins that weigh 5 pounds. So we're going to put in 5 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Don't let that one type that in for you. All right. And it says there are 3 that weigh 5.5. 1, 2, 3. There are 11 that weigh 6 pounds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 3 that weigh 6.5. 1, 2, 3. We're almost there. Hang in there. There are 3 that weigh 7. 1, 2, 3. And there is 1 that weighs 7.5. 7.5. All right. So we got all our data in there. If you need to go back and pause the video and catch up, that's fine. Now let's go ahead and draw a histogram of this data. Remember how to do this? Go to the command line, and actually you can just type histogram. Let's try it that way, histogram. Perfect. So you can either pull up the word from the menu, or you could type histogram. Left parentheses, data set. We're going to use, again, our data is called X1. It's in the X1 column. If we wanted to change this, we could name it like P for pumpkins if we wanted to. If we did that, we would have to put P in down here. Whatever the name of your data column is what you put in the first column for your histogram. And now we need to figure out our bin width. Well, let's go back and figure that out. We didn't take time to figure that out. All right. So we had 30 pumpkins. The square root of 30 is about 5.47. So we're going to use 6 bins. And we take the maximum value, which was 7.5 pounds, minus the minimum value, which was 5, divided by 6, and we get 0.4. I think bin width of 0.5 would be a little bit nicer. So let's go ahead and choose that and go back to Desmos and choose 0.5 for our bin width. And let's use our count and left alignment and click our arrow. And there is our nice pumpkin histogram. And we can see our counts. There were 9 of weight 5. There were 3 of weight 5.5, etc., all the way up into 1 of weight 7.5. You can see the scale over here on the left side of the axis. All right, one last topic for this histogram video. And the last topic is frequency table. So here is our frequency table for our pumpkins. This means that for the weight 5, there was a frequency of 9 pumpkins. For the weight 5.5, there was a frequency of 3 pumpkins. And you can see why this would be really useful to use instead of just listing 555 9 times. It's a little bit easier to read. We can also use this to help us come up with our relative frequency. So our relative frequency is just going to be the number of our frequency. So 9, what did I do? I don't know, go back. 9, there we go. That's the number in our frequency table. and you're going to divide that by the total number of pumpkins. So 9 divided by, oops, that did not come out very neatly, sorry. 9 divided by 30 is our relative frequency. Let's get a decimal approximation for that. So 9 divided by 30 is about, well, it's exactly 0.3. That's nice. 0.3. Or sometimes people write it as a percent. This is the same as 30%. Remember when you take a decimal to a percent, 0.3, you move the decimal place 2 places to the right, and you fill in with the zeros. So that got me to 30%. Let's go ahead and fill this frequency table out for all of our values. The next one is 3 weighed 5.5 pounds out of 30. That's going to be 1/10, 0.1, or 10%. 11 out of 30. That's 0.3666 repeating. We're going to call that 0.367, rounding to the thousandth place. And that's going to be 36.7%. Right, the next one is 3 out of 30. Again, we've done that a couple times, so we know that's 0.1, 0.1, or 10%. And finally, 1 out of 30. 1 divided by 30 is 0.1 divided by 30 is approximately, I should do approximately here, 0.033. So we're going to call that 3.3%. If we add up all these percents, you will end up with 100%, or which is good because we better account for everything. So 100%. If you add up all these decimals, you will get 1 whole. All right, so that's frequency versus relative frequency. A lot of people like to think of the percent. So 30% of the pumpkins weigh 5 pounds, or 10% of the pumpkins weigh 6.5 pounds. Now we can do that on our histograms as well if we would rather look at the relative frequency or the percents. Let me show you how to do that really quickly on our histogram that we just made. So remember where I said we chose count? We can actually choose relative here. Now it doesn't look very good, right? Because we're all in percent and they're way down here. So go ahead and zoom fit. The shape of the histogram is still exactly the same, but the heights on the y-axis are percents now instead of, or decimal percents instead of counts. So 30%, 10%, etc. All right, that's it for this section.